In the chapter Electric Charges and Fields, we now solve some multiple choice questions. First, we will take the MCQ based on the electric field lines. First question is, the given figure shows electric field line of forces due to the charges Q1 and Q2. What are the sign of these two charges? Here, from the property of electric field lines, we know that field lines originate from the positive charge and field lines terminates at the negative charge. Therefore, from the figure, we can see that field lines are entering at the charge Q1 as well as at the charge Q2. So in this way, we can say Q1 and Q2 both are negative. Hence, option C is the correct option. Here we have used the property that electric field lines must originate from the positive charge and must terminate at the negative charge. A metallic solid sphere is placed in a uniform electric field. Uniform electric field refers the same direction and magnitude in the region. The line of forces follow the path. We know that in solid metallic sphere, charge resides at the outer surface of the metallic sphere and field is zero inside. Therefore, field line cannot exist inside the metallic sphere, hence option 2 and 3 are incorrect. Also, the field lines are normal to the surface. Therefore, option 1 is also wrong and option 4 is the correct option. Therefore, option D is the correct option. So, property used are, first property is that electric field lines cannot enter the metallic body and hence electric field inside the metal is zero. And another property used is that electric field lines must be normal, that is perpendicular to the surface of the conductor. Next question is, a metallic shell has a point charge Q kept inside its cavity. Which one of the following diagram correctly represents the electric field lines of forces? We know that, as done in earlier question, that electric field inside the conductor or a metal is zero. That is the first point. And another property is that electric field lines are normal or perpendicular to surface. Same two property will help to solve this problem. Here, field lines cannot enter the metallic body. Therefore, this option D is incorrect because field lines are shown inside. Similarly, this option A is also incorrect. Another property is that field lines must be perpendicular to the surface. Here in option B, the field lines are not perpendicular to the surface of the metal, hence this is wrong, while in case of C, the field lines bend and are normal to the surface. So we can say option C is the correct option. Next question is, a long cylindrical shell carries the positive surface charge sigma in the upper half and negative surface charge minus sigma in the lower half. The electric field lines around the cylinder will look like. From the property of the electric field lines, we know that the electric field lines originate from the positive charge and these field lines are shown for the isolated positive charge. Similarly, for isolated negative charge, field lines are terminated at the negative as shown in the figure. But if these two charges are not isolated, that means kept nearby, then field lines will like starting from the positive charge and terminating at the negative charge. So this is the representation of the electric field lines from a combination of the positive and the negative charge. Using this property, we can see that this B is wrong because for nearby charges, the field lines originating from positive must terminate at the negative charge. Similarly, C is also incorrect. Also, field line cannot form the corners as shown in the figure D. So D is also wrong. Hence, option A is the correct option. Here we have used the property that electric field lines cannot form the corner as shown in the figure D. three positive charges equal value Q are placed at the vertices of a equilateral triangle. The resulting line of forces should be sketched as in. From the property of the electric field lines, we know that field lines originate from the positive charge and terminate at the negative charge, and they do not form the closed loops. In the figure D, field lines are shown as a closed loop, so this is a wrong option. Similarly, one field line is also shown closed loop in figure B, so it is also a wrong option. And field line must originate from the positive charge and terminate at the negative charge, but in the figure A, the field lines are shown between the two positive charges. Therefore, A is also incorrect option. Hence, the option C is the correct option. We can also visualize this, like if this is a positive charge and nearby another positive charge, then the field lines will be like as represented here due to the repulsion between the charges. So these field lines originate from the positive charge and they do not terminate, or we can say terminate at infinity, because in the figure no negative charge is shown. So similarly, if we can compare with the figure C, option C is the correct option. Here property uses electric field lines cannot form the closed loop. Next question is, a few electric field lines of a system of two charges Q1 and Q2 fixed at two different points on the x-axis are shown in the figure. These lines suggest that if we visualize the figure, the field lines originate from the charge Q1, so it is a positive charge, and field lines are terminating at Q2. This field line actually this should be inside, so this Q2 is a negative charge. And density of the field lines is more near the Q1, so we can say the magnitude of Q1 is more than the Q2, hence option A is the correct option, while the B will be incorrect. Now we have to find the electric field. We know that electric field due to the point charge is 1 by 4 pi epsilon naught. Q is the charge and distance of the point from the charge is R, so it is 1 by 4 pi epsilon naught Q by R square. Because Q1 is more than Q2 in magnitude, so to neutralize the field due to two charges, we should have that distance of the point where E is 0 should be greater than distance of that point from the charge Q2. Hence, we can see that such point can be on the right side of the Q2. Say this is the point P. So electric field due to Q1 will be outward and electric field due to Q2 will be inward towards the Q2. And these two are in opposite direction and should be equal in magnitude, giving the net field 0. Hence option D is the correct option. So A and D are the correct option. Next question is, which among the curves shown in the figure cannot possibly represent the electric field lines? In figure A, the conductor is shown and we know the property of the field lines that for a conductor, field line must be normal to the surface of the conductor, while in the figure there are different directions of the field lines other than the normal, so option A is the incorrect option. Another property of the field lines that they must originate from the positive charge and must terminate at the negative charge. If we consider one of the charge say negative, here field lines are terminating as well as originating from it, so option B is also incorrect option. Option C is the correct because it is representing the two positive charges and field lines are rippling. If we consider the option D, here field lines are crossing and the property of field line says that two field lines never cross because it will say there are the two possible direction of the electric field which is not allowed. So option D is the incorrect option. Similarly, the option E is also incorrect because field lines never form the closed loop. This closed loop cannot form. And also field line must be perpendicular to the surface of a conductor. So option C is the only correct option in the question. Here we have used one of the property that electric field line never crosses.